All right, so we are into Unit 6, Meteorology. We're going to start with the intro unit and looking at the early atmosphere and the atmosphere in general. So the early atmosphere consisted of these gases, mainly these three: water vapor, carbon dioxide, and nitrogen. Though I will say that due to volcanic eruptions, other gases were released, but not like the typical ones you would think. So these are the ones you would see through volcanic eruptions. And according to our page 8 of our reference table, a little bit further on, after the Earth really started getting going, you had the first life forms on Earth that were probably anaerobic bacteria that did not require the oxygen. Remember, they were found usually in water, and this is what the stromatolites looked like. As the plants evolved and they started to come up onto land and developed, they were able to suck in the carbon dioxide and water and release oxygen, also known as photosynthesis, which hopefully you've learned in Living Environment. Once all the available iron on Earth was oxidized, which is why you see the orangish reddish dirt, that was because of the oxidation of iron. And the oxygen began to accumulate in the atmosphere. About 4 billion years into Earth's existence, the fossil record revealed abundant ocean-dwelling organisms that required the oxygen to live. So this, as soon as the stromatolites and whatever was giving off all this oxygen, once we had all this oxygen available to everything, then we started to see life. Part of the atmosphere is studying weather. Weather is the state or condition of variables in the atmosphere for a given location at a given period of time. So it's like, what is the weather of Syracuse, New York? Not what is the weather of New York in general. So energy from the sun causes weather. Throughout the seasons, it heats our world, some parts more, some parts less. Some parts we get this, some parts we get this. So winter is more this, summer is more this. Not that we ever get this where we live. This uneven heating causes the Earth's atmosphere to react and become a gigantic engine that produces a variety of weather conditions, from water, or wet water, snow, sun, tornadoes, hurricanes, all of it. We have the same amount of solar energy heating different amounts of surface area. And so some variables that we see with the weather is temperature, wind speed, and moisture. All of these, they talk about meteorologists. They'll tell you what is the temperature going to be like, what is the speed going to be like, and what is the moisture content. That does come into play when you're looking at freezing temps, when you're looking at heat, humidity. That definitely comes into play. And we will talk about that a little bit later. And then they like to talk about pressure. Pressure changes also tell you if there is going to be wind. All right, important part. We have weather instruments. So the weather instruments that we see right here are given these different forms. All right, so the first one that we see is going to be called a barometer. It looks kind of like this. This is one of the types of barometers we have. We have a couple different types. There's 2 types. So this is an anaerobic barometer. Right here, you'll see these. They tell you the pressure. Then you have this over here, which is a rain gauge. Right here, you'll see that it's got little lines to measure how much rain fills it up. Basically tells you how much rain has fallen. Then we have the normal thermometer right there, which tells us the temperature. And then we have over here, and this, don't get this confused with other things. It's a wind vane or a weather vane. It tells you what direction, south or north or east or west, that the wind is blowing. This next thing, which is this, or I even got a bigger one right here, is called an anemometer. And this one tells you how fast the wind is blowing. Not which direction, it tells you how fast. See, it can measure how fast it's spinning, which tells you how fast the wind is going. All right, and this last thing that is down here, this is called a sling psychrometer. It has a wet side, which has like a little bit of fabric on one side and a dry side thermometer on the other, and it slings around in a circle. It measures the dew point and relative humidity. All right, with it, the atmosphere again. It is a thin envelope of air right here that surrounds the Earth and consists of a mixture of gases. The atmosphere is composed of what 3 main gases? If you don't remember, let's look to page 1 of our reference table. So the part of the reference table you're going to look at is right down here, where it's got all this lovely information. It will show you that nitrogen is 78% by volume. If you're going to look over in the troposphere, all the way over here, 78% by volume is nitrogen. This is for the biosphere, living. We do need nitrogen in the soil for plants to grow and prosper. And then you'll notice at 21% is oxygen. So that's 21%. And then all other is 1%. Oxygen is important because we breathe it. Okay, so things to mention, this is the other 1.4%, and you'll notice water vapor is 0.4% of the gases, and this is water vapor is used to transport heat. It creates greenhouse gas that warms up the earth. The water vapor does warm up the earth. It also creates weather. Then you have methane. It is more potent than carbon dioxide. This is like gases, certain gases. And then you have ozone, that's O3, oxygen, like 3 oxygens together. No, it's not good for us, but this is a good thing. It helps protect the earth from damaging UV. And then aerosols. Aerosols could be like dust particles. It helps in cloud formation. So, a structure of the atmosphere, sorry, my face is in the way. This you can find on page 14 at the top, right here. Very, very important. You're going to find that. This is the structure of the atmosphere. So the troposphere, as the temperature decreases, it goes down as it goes up in height. And this is where all weather occurs. If you look at this, the water vapor is what you need for weather. It's mostly right here in the troposphere. Very little of it gets up into the stratosphere. And this extends all the way from the surface of the Earth to 10 to 12 kilometers. And this is also where we find the jet stream. It's in the upper troposphere. That jet stream also brings us a lot of our weather. The next thing we're going to look at is the stratosphere that is above. So we have the troposphere and then the stratosphere. One thing you're going to notice that the temperature does increase as you go up. So the troposphere decreases, the stratosphere increases with height. And it extends from the tropopause, which is this layer in between, to about 50 kilometers. One of the things you'll notice, the ozone layer is in there. And then we have the mesosphere. It's bounded between the mesopause and the stratopause. There's not really a lot to say about the mesosphere. It does protect us from meteors, but there's not a whole bunch to say about it. Then we have the thermosphere. The thermosphere is all the way at the top before you get out of our atmosphere. Again, you notice that temperature increases with height, and it's the layer above the mesopause. What it has in it is called the ionosphere with 3 different layers. You got the F layer, E layer, and D layer. This is where our radio message and stuff, it bounces off of there and hits back towards us. And so that's the really, really important part of the thermosphere. And yes, this is also where like shuttles and stuff that don't go out of the atmosphere, they kind of hang out in there. All right, so we do have an energy budget. That means the solar energy goes somewhere, is deflected and absorbed in different parts. And you'll see here, we have incoming solar energy 100%. And it's reflected by the atmosphere, reflected by clouds, reflected by the Earth's surface. And then you have absorbed by the atmosphere, absorbed by clouds, and then absorbed by the land. And eventually, it gets radiated out to space from the clouds and atmosphere, radiated directly from the Earth. And it's carried to the clouds and the atmosphere by latent heat and vapor. You'll notice we have a lot coming in and some coming out. We don't contain everything that we get. All right, so that is it for the notes for the moment. And if you have any questions, please don't hesitate to ask. I hope you guys have a great day.